So now we're going to look at the cardiovascular system and the adaptations in terms of anaerobic training. It's important to note that there aren't many modifications made to this system because the majority of these adaptations arise from aerobic training, as we are going to look at later on. An example of training, though, that has been shown by studies to increase the anaerobic capacity of the cardiovascular system is HIIT training. And this is a form of cardio training which consists of short bursts of hard work that the athlete maintains throughout the whole workout. So they maintain this maximum intensity continuously, but they do have short recovery periods between the sets. Even though it is an anaerobic method of training, it has been shown to benefit the cardiovascular and respiratory systems, which we're going to talk about next. Here on the right we have a graph demonstrating our heart rates in the Wingate test from our investigation data. And we can see that from the gradient of the line that our heart rates increase dramatically because of how high intensity and short duration the test is. So we're maintaining the force over this high intensity over such a short duration, but we're having to produce a lot of force. And we can see that at rest the participant had a lowering resting heart rate of around 55 beats per minute. And the average is 60 beats per minute, so this is showing that they have a really good level of fitness. And at the pre-test, the heart rate was at resting levels of 60 beats per minute, so we can see a slight anticipatory rise, which could be due to feeling nervous or anxious about how the test is going to work, just the athlete sort of overthinking and sort of getting slightly stressed. Then at level 6, we can see that we have quite a steep gradient, quite a steep increase, and the heart rate increased to 120 beats per minute, which is double from the 60 beats per minute. And then we start to see from level 6 to the post-test that the heart rate starts to decline quite quickly, which could highlight that the participant was not necessarily working in their maximum anaerobic threshold, as in this test they should have been working in their 80% zone. But if we work out this from the participant's heart rate using the equation 220 take away the participant's age, which was 17, the participant should have been working at a heart rate of 203 beats per minute. And then to work at 80% of that, they should have been working at 160 beats per minute in order to reach the anaerobic threshold. So therefore, the athlete was not working within the anaerobic threshold. And so this test maybe isn't necessarily as accurate because it doesn't necessarily reflect the true results. But also for an athlete like a weightlifter, strength training will cause an individual's heart rate to rapidly increase because they're working in their maximum anaerobic threshold. And because of the amount of force needed to be generated very quickly, the heart has to respond to these demands in order to pump more oxygen around the body in the blood. So therefore, heart rate's going to increase because the cardiac output increases and stroke volume increases, which we're going to come to later on. And similarly with the respiratory system, there aren't many anaerobic adaptations, so we are going to address these in the aerobic section. But due to the evidence shown, we can see that similarly HIIT training also has the same impact on our breathing rate and forces it to increase. And also by the investigation data shown on the right in the Wingate test, in the graph, we can see that between rest and pre-test that there has been an anticipatory rise from 10 beats per minute to around 12, and so this anticipatory rise is also showing the factors like anxiousness or the hormones responding to this fight-flight response. And then we can see that there's a very steep gradient from 12 to 27, which shows the rates rapidly increased, and it showed that the athlete was nearly working at their maximum breathing rate. And after this test, we saw that the athlete's breathing rates remained elevated for quite a period after. This is showing that the athlete was actually having to repay the oxygen debt that they had accumulated and remove the waste products like lactic acid. And a more elite athlete that has undergone long-term training would be able to reduce this recovery time and replenish the stores much more quickly due to the long-term adaptations of the respiratory system, which we're going to look at later. So long-term training can have some really beneficial benefits to an athlete. So now we're going to look at the neuromuscular system adaptations. And first of all, we need to establish that during any contraction, whether it is an isometric, isotonic, or isokinetic contraction, there are impulses that are sent from the brain by motor neurons to the neuromuscular junction, where they can be carried across the synapse and bind to receptors on the postsynaptic membrane and taken to the fibres to initiate a contraction. And these are achieved by motor units, which are composed of motor neurons and muscle fibres which coordinate together in order to produce the contraction of the skeletal muscle. Strength training is one way an athlete can improve these contractions, and the types of exercises in strength training are actually known for developing and toning muscles, helping to develop and sort of maintain the integrity of bones, increasing metabolism by increasing lean muscle mass to build stronger connective tissue. So this means the joints become more stable and decreases body fat. So it's important to consider that strength training is not just beneficial to athletes like weightlifters, it's also beneficial for just general life, for life in general. And as we grow older, because muscle mass naturally sort of diminishes with age, the idea of taking part in strength training helps to sort of increase the muscle mass and to prevent this muscle loss, so we can rebuild and sort of maintain our muscle mass, so we don't cause conditions to our body which can then prevent our daily activity and sort of compromise our independence. So in the body, each movement has to be continuously controlled by receptors which are sensitive in remaining conditions. These are proprioceptors, and they give continuous feedback on the position of limbs. So examples of proprioceptors are the muscle spindle and the Golgi apparatus, and these are responsible for detecting changes in flexibility and strength of the tendons and muscle fibres, and sending this feedback back to the brain, where the brain can then respond to this and then send an impulse back to the muscles in order to stop the contraction. They help muscles from overextending and over sort of training to prevent injury, so the muscle fibres don't experience the micro tears, which can then actually prolong an athlete's recovery. And then this linked with the idea of increased tendon strength. So the tendons are the tough bands of fibrous tissue which are designed to withstand tension between the muscles pulling on the bones. And these tendons therefore then adapt to the loads that we increase in our sports. And then by increasing their flexibility and strength with this like regular exercise, they can sort of withstand more force and then prevent the idea of injury. And this links in with the idea of, if we have these proprioceptors detecting these changes, then we can sort of make the efficiency of the transmission through the neural pathway more efficient through cellular adaptations. And these are changes within a cell structure, which can be things like modifications to the neurotransmitters and biochemical responses from long-term exercise. We sort of achieve this by motor unit adaptations. So by having more motor units initiating the impulse through the neural pathway, it will be faster, and therefore the strength of the contraction becomes greater. And this is also to do with, as we previously mentioned in the previous video, by having the myelinated axon helps with the wave of depolarization to shift the charge by saltatory conduction in order to speed up the contraction to the muscles, so we can generate the force much more quickly. And so groups of motor units working together provide a coordinated muscle contraction. And it's important to note that they are all the same type of fibre, so they would all be slow oxidative fibres, fog fibres, or fast glycolytic. There wouldn't ever be a mixture of them. And the fibres are forced to contract. So the number of muscle fibres affect the number of motor units. The larger the muscle mass would mean there's an increased muscle fibres would have a greater motor neuron innervation, so they would require more motor units in order to be innervated. And the graph on the left, showing motor unit recruitment graph, shows that the stronger the muscle and the number of motor units basically affects the fatigability of the muscles. The weaker muscles have a slower resistance to fatigue, and therefore suited for more aerobic activities like marathon running, triathletes, athletes that sort of are producing a smaller amount of force over a longer duration. And as we see the graph increase, we can see that the stronger muscles are more fatigable because they are producing more force in a shorter duration. So they require high intensity, and this is at sports anywhere from shot puts to even game sports, particularly like in football when they have to generate a large amount of force to kick the ball. Weightlifters, as we've been using the example of, would require more force in order to sustain their weight and potentially lift it and hold it over their head as well. So their muscle fibers will be constantly contracting to initiate this. And also the central nervous system works in two ways, and these are spatial and temporal recruitment. Spatial recruitment is recruiting more units for more force until all the muscle fibers are activated in exercises like weightlifting, and as we said, so that all the muscle fibers in the arms and the legs are initiated in order to sustain this force and hold this position, so we can sort of maintain the weight above our head and not allow our muscles to collapse. While temporal is the frequency of the contraction and produces a greater force than a single contraction. This is sort of sustaining the force over time as well. So an athlete, in order to create the desired force they need in their sports particularly like weightlifting or high jump, where the individual needs to create a large amount of force in order to sustain the weight or produce the momentum needed, will allow the motor units to initiate a faster response of more impulses. So by participating in long-term training and implementing strength and power training specifically into a program, will allow their bodies to adapt by recruiting more motor units and particularly fast glycolytic muscle fibers for the anaerobic sports. So they can increase the maximum activation of the target muscles, so the weightlifter is able to lift more resistance and the high jumper is able to perform at a higher level, so it can help the athlete actually place better in the competition and sort of maybe even achieve their personal best, because the long-term adaptations mean that they can generate a larger amount of force, and then therefore their proprioceptors will detect these changes without causing injury and micro tears to the muscle fibers, which could actually sort of decrease the fitness level and sort of capability of the athlete. Well, this is sort of following on from what we've been saying about the adaptation and sort of applying it now to the sporting example. So the graph on the top showing benefits of strength versus strength level represents the training of an anaerobic weightlifter, and that the principle for any athlete is the same. The longer you train, the more long-term adaptations will be produced in the response to the stress. To avoid the risk of overtraining and sustaining an injury in order to see results, progression occurs at a much slower rate due to implementing the progressive overload principle. The graph shows that as the athlete's strength increases, this then benefits the strength of the athlete. We can see that for a beginner weightlifter that is weaker than an elite athlete at first, when they start to train, their strength increases relatively quickly, and therefore they see more benefits of the training. And this is due to it being much easier for a beginner to see results.